is you have a product rule. Product in math means what? Multiplication. So if you have a function y, that is two functions multiplied together. Okay? We have a whole rule for how you find the derivative of this, because you know how when we did the basic derivative rules, we said if there's plus and minus signs in between, you can do derivative of one part, then the derivative of the next part, then the derivative of the next part. That works for plus and minus. It does not work for multiplying. So you can't just say the derivative of this is f prime of x and the derivative of this is g prime of x and multiply those together. You get the wrong answer. So we need a specific rule for this, and so here is our rule. Y prime is equal to. You begin by taking the derivative of the first function, f prime of x. You multiply that by the second function, not the derivative. Then you add to that the original first function multiplied by, anyone want to take a guess? The derivative of the second function.
So it doesn't matter which order you do it.
The only reason I'm going to write it in this order is because in the quotient rule, it can be harder to remember because it does matter order on that one. Because this one with a plus sign, it does not matter order. You could do the first one or the second one, it doesn't matter. In quotient rule, there is a minus sign and it does matter. So the way we write it in product rule is in the same order that we're going to write it in quotient rule so that it's easier to remember both of them together. There's a point to it, okay? So what this means is something like example 1. I have been given y is equal to these two things multiplied together. What is the first function there? Like if I had to split that into two things, x squared. The second function is sine x. Are we all okay with that? Okay, so I've got one function. I'm going to just kind of box them here. One function here.
So would that be like f of x and g of x?
Yes. So that's my f of x and g of x in that notation up there. And I don't usually, like if you hear me talk this through to myself, because I like to talk to myself as I do work, I will always say, I don't memorize it exactly in that notation, which sounds funny, but it'll make sense in a minute. Like, I talk myself through and I say derivative of the first function times the second function plus the first function times the derivative of the second function. So I don't use the f of x and g of x in my head. I just use that. And I don't know if that will help anyone, but it does to me. So
Also, it's a derivative sandwich.
it is. It's like the outsides and then the insides and flipped. Yes. And they can't be multiplied by themselves. So if I walk through that one piece at a time, this means my y prime is going to be, I start with the derivative of the first function. So what is the derivative of the first function? 2x. I multiply that by just the second function, no changes, sine x. I add to that the first function, no changes, which is what? X squared, multiplied by the derivative of the second function, which happens to be cosine x. If there is something you need to do to clean it up, like in this case you can't, but some of them, your first function will have x's and your second function will have x's with no signs, and you'll have to actually like FOIL or something. So you can clean that up. This was a great example for a first one because it's very clear and there's no multiplying out, okay? So the need for that is two functions multiplied together where I cannot simplify. Because there was no way I could combine that x squared with the sine of x to make it something simpler, okay? So let's talk quotient rule, okay? And then we will do other examples, okay? Yes? No, you do not, okay? There will be times that, like, if you look at the textbook answer, they may make it look slightly different. If you can see what they did, generally speaking, you are good leaving it where yours is. We'll have some rules of thumb. You can't leave negative exponents in your answer. Stuff like that. But we will simplify it to a certain place.
Like here, even if you wanted, like, could you pull off that x, or is that?
It is not going to help you.
Yeah. Okay.
So, my quotient rule. Quotient rule comes into play when we are taking one function and dividing by another function. Okay, so this is where I use my f of x and g of x again. And so my quotient rule says my derivative comes by doing the derivative of the top function times the bottom function minus the top function times the derivative of the bottom function. all over the bottom function squared. Now, I'm going to pause there. When I walk through this one, let's just plug it into our formula. F prime of x. And this is where I start to get confused with the fact that, like, in the quotient rule, you use y and f of x and g of x. So this is where I talk through, like, the language to myself. Instead of calling them f of x and g of x, that's where I say this represents the derivative of the top function. This is the bottom function. So, like, I will literally say those words to myself as I walk through it. That's how I memorize my rules. So I will say we begin the quotient rule with the derivative of the top function. What is the derivative of the top function? 3. I multiply that by the bottom function, which is what?
3 times x squared.
So usually on my first step, I'm just going to do like my setup. I'm not going to try to distribute, FOIL, do all of that. I just want to get the setup. Then I have a minus sign. That is followed by the top function.
Should you go ahead and distribute the...
You can, but if you're going to screw something up,
Don't do it.
don't do it.
Don't do it yet.
Yeah, I would just do the setup.
Okay.
So then I have the top function. That's 3x plus 1 times the derivative of the bottom function,
Which is just 2x.
2x minus 3. And that right there is why I don't distribute the negative, because what am I actually going to have to do first? FOIL, then distribute the negative. So I'm going to get myself all messed up if I do it differently. And then it's all over the bottom squared. General rule of thumb, I will fully work out the top of this. I don't usually square the bottom. And this is why. The only time something's going to simplify with the bottom is if there happens to be a factor that is the same as that can cancel. If you FOIL it out, you're never going to catch that. Okay, so I leave the bottom alone. So what am I going to do on the top now? I am going to distribute my 3. This is going to give me 3x squared minus 9x. I'm going to keep my minus in a big old set of parentheses and FOIL on the top there. So that's going to give me 6x squared minus 9x plus 2x minus 3. Then I'm going to distribute my negative and combine like terms. So I get 3x squared minus 9x minus 6x squared plus 9x minus 2x plus 3. And then my final step will be to combine all of my like terms. I get negative 3x squared. That is going to cancel there, so that's minus 2x plus 3. If you think the top might factor, then maybe try it. This you'd have to pull a negative, but I'd also look at like the 3 and the 3. Really, am I going to get any factors when I have 3x and x and 3 and 1 that are going to add up to negative 2? No. So I would leave it here. Yes, ma'am. Some of the functions in example 3 need the quotient rule. Some of them do not. Okay? I want you to look at A, B, and C. If there is any way that you can simplify A, B, or C so that you do not have to use the quotient rule, you should do that. So does anyone see any of those 3 that you would not have to use the quotient rule on? C. Why C? Yes, so I can treat this like exponent rules. It's like you're moving it to the top, but remember this is like x to the first. This is like x to the 1/3. What do my exponent rules tell me to do here when I'm dividing?
Subtract.
Keep the base, subtract the exponents. This gives me x to the 2/3. Can I use my normal derivative rules here?
Yeah.
Yeah. I can just say y prime is equal to, what do I do with my exponent? 2/3 x to the negative 1/3. So how do I write my final answer?
2 over 3x cubed root.
Yep, you could do the cube root of x, or you could leave it as x to the 1/3. You need to recognize the times like that when you should be able to simplify, because I could use the quotient rule on that. It would take twice as long, and it wouldn't simplify very quickly or easily. You don't want to use it unless you have to, okay? Now, there's another one that I don't have to use the quotient rule on. A. Why A?
Because the 1 and 1
Okay, look at the denominator. Is there an x in the denominator? No. Therefore, it's not like an f of x, g of x function. G of x is just a number. I can treat this instead like a division problem. And just break it down that way. When there's only one thing on the bottom, one, no plus or minus signs, you are usually able to simplify. So notice that's the similarity between A and C. A has only a number on the bottom. C had only an x on the bottom, no plus or minus signs. So you can simplify those and just take the derivative normally. So in this one, what is my derivative of 2/3 x? 2/3, what's the derivative of 1/3?
0.
0, you're done. Like you really should not use quotient rule on that. You see what I'm saying? Okay?
Quotient rule if like you can't break it down or just
Yes. So B is a perfect example for why I need the quotient rule. I can't divide 2x plus 1 into 3. As soon as there's a plus or minus on the bottom with an x, you've got to use quotient rule. There is no other way around this one, okay? Well, okay, correction. We will learn when we learn our last rule called chain rule that there is one other way to do this question, okay? But in the case of what we have right now, we can only use quotient rule. So let's practice it one more time. You do have to be careful with quotient rule on this one, only because the top is so simple.
Yeah.
So when I go through my quotient rule, again, if I'm using my language, I start with derivative of the top. What is the derivative of the top? 0 times the bottom minus, in my language that I use the top, times the derivative of the bottom. What's the derivative of the bottom? 2 all over the bottom squared.
Right.
So what's going to happen to that whole first part?
It's just gonna be some
That's gone. This is going to give me -6 over 2x plus 1 squared. Again, when we learn chain rule, we're going to learn a second way to look at that. But right now, I don't have a choice because I can't simplify and I can't divide. Okay? What questions do we have on this?